Ionic strength is something we should talk about when we're diving a little deeper into advanced equilibrium topics. So I've noted the formula for calculating that, which is the symbol mu for ionic strength, and the units for this are in molarity, is 1/2 of the sum of all of the concentrations of the ions that are dissolved in the solution times the charge of those ions that are dissolved in solution. We add up all of these, divide by 2, that's the ionic strength. So let's do some examples of this. Let's start off with a very simple one of just 0.1 molar NaOH, or NaCl. Although NaOH would be the same since the ion charge is the same. Anyway, so we have 1/2 times everything, and then that's going to be 0.1 molar Na times the charge squared plus the concentration of the chloride ion times its charge squared. And you'll notice that this is just 0.1 times 1 and 0.1 times 1 and then divide by 2. So it's actually still just 0.1 molar. And that's the case when we have two ions that are singly charged like this. So that's a very simple case. Now let's look at something a little bit more complicated. Let's see what happens when we have an ion that's not just a charge of 1 or -1. Let's look at sodium sulfate. Still 0.1 molar. So we'll take 1/2 again, and then we'll multiply it by the concentration of sodium ions in the solution, which is that there are 2 sodium ions for every 1 sodium sulfate, so the concentration is actually 0.2. In this case, still a charge of +1, and then we need to add in the amount of sulfate. There's 1 sulfate for every sodium sulfate, so 0.1 molar. And the charge is 2 negative, so do that. Now, here we square -2, so that's going to be a 4. So that would be 0.4 here. And that is 0.2. This is a squared. So 0.4 plus 0.2, that's 0.6. Divide by 2, 0.3. So you can see how dramatic the effect is just by changing one of the ions to a +2 charge. Now, I should note something very important about calculating ionic strength that the formula does not really account for. You can actually only count on the formula working if you have a +1 or a -1 charge in it, somewhere in there. So if one of the ions in there is a single charge, single valency. So you wouldn't, for example, want to try this with magnesium sulfate because that's a +2 ion and a -2 ion, and the ionic strength formula will just not function very well. The reason for that is it's more likely for it to form ion pairs. That is, basically, you will have magnesium sulfate and the 2 ions will be attached to each other in solution, at least some of them will. Not all of them will break apart easily just because of the increased attraction. That doesn't mean the solubility is necessarily less, although generally speaking, when we have more charges on something, the solubility will go down. It can still be dissolved in the solution as just that one atom of magnesium and one sulfate ion attached together, but they'll be together, and so then it will not add to the ionic strength of the solution. So just keep that in mind. Now, you can just do the ionic strength calculations for single substances like this, or if we had a more complicated solution, let's say we had 0.5 molar sodium nitrate, and in the same solution we also had 0.2 molar calcium nitrate. So that's possible to make, right? We can just add some sodium nitrate into the solution and add some calcium nitrate in to make the appropriate concentration. So let's see what effect that has on the ionic strength calculation. So we'll just go ahead and start with the positive ions first. So we'll have a 1/2 times my concentration of sodium, which is 0.5 molar, times its charge squared, plus the concentration for calcium, times its charge squared. And then we need to add in the concentration of nitrate. Now there's 0.5 molar nitrate from the sodium nitrate, and there should be 0.2 times 2 molar for the calcium nitrate. So that's 0.4, 0.5 plus 0.4, 0.9. We'll multiply it by its charge squared. And then if we add up all of these terms, we should get 1.1 molar. So I do this just to illustrate that you can have multiple ions in solution, and we can add them all up, and they will all contribute to the ionic strength of the solution.